So in this video, we're going to take a look at how to apply Pythagoras' theorem to some more complex examples. And before we watch this video, you should understand Pythagoras' theorem. So I will show full workings, but let's see if we can figure out some problems. So in both of these two examples, A and B, we've got to find out x, okay? And the situation is made from two right-angled triangles. Now, in A, our general idea is that we need to, at the end, consider what I'm drawing in red here. But at the moment, we don't yet have enough information to use Pythagoras on that red triangle. So we need that hypotenuse. And so to find that, I'm going to have to first think about the blue triangle. So to find that side, and let's just call it C for a second, okay? C squared equals A squared plus B squared. That's Pythagoras. So if I were to use the blue triangle, I could say that C is going to be 6 squared plus 8 squared square rooted. So that is going to be the square root of 36 plus 64, which is the square root of 100, which of course is 10. So this side is 10. Now I'm going to write that in red because now we have enough information to find x. Because if I'm thinking of that red triangle, well, let's write it out again. C squared equals A squared plus B squared. Well, we know the hypotenuse, so we know that C is 10. So C squared equals 7 squared plus x squared, which is going to mean that 10 squared minus 7 squared square rooted is going to give us our value we're trying to find. Well, that means the square root of 100 minus 49, which is the square root of 51. And if I do that on a calculator, I'm going to have 7.14. Now, we're not given units, so we'll leave it like that. 7.14 is going to be our value of x. Let's have a look now at part B, see if we can apply the same situation here. So just like in the last example, we're going to need to find some information out first. So let's consider this blue triangle and let's work out that hypotenuse of that blue triangle. Well, that will be 4 squared plus 5 squared square rooted. Okay, I'll call it C again. So that is going to be the square root of 16 plus 25. That's the square root of 41. Now, typing that into the calculator, that will come out at 6.40. Okay, now let's think of that red triangle with that x in it. Now this time we're looking for a slightly different thing to last time because we're looking for the hypotenuse, right? So if I do 6.40 squared plus 3 squared square rooted, that's going to give us x. Now, to avoid a rounding error, I already know what 6.40 squared is. I can use my previous work. So that is going to be 41. So I've got 41 plus 9 square rooted equals x. So x is going to be the square root of 50. And if I type that in on the calculator again, I can tell you the square root of 50 is 7.07. So there's our answer there. So in both of these two examples, we've had to use Pythagoras once to get some information and then again to find our answer. Let's take a look at some other examples of where we can use Pythagoras. So in this particular case, we've got some unknowns and we're going to have to use those carefully. Right, so we're going to find x in both situations. Let's start with A. So in this case, well, we can just start applying Pythagoras in the normal way. Those two sides squared add to make the hypotenuse squared. So let's just write that out. X squared plus x squared equals 20 squared. Well, x squared plus x squared, if we know our algebra, we can collect those up together. That's going to be 2x squared equals 400. Or let's just solve this as an equation. We can divide both sides by 2 to get x squared equal to 200. And now all we have to do is square root both sides. So x is the square root of 200, which is 14.1. So we've managed to find our x there. Let's go on to B. Now we've got to be a little bit careful here, but it's the same principle. So we are trying to find x again. So let's just write this out, and we'll use the blue pen. Okay, so x squared plus 4x squared is going to be equal to 8 squared. Those two sides sum and add to make the hypotenuse squared. So let's write this out. X squared plus 16x squared equals 64. Again, be very careful here. We have to square both the 4 and the x. So it's not 8x squared, it's 16x squared. Now we can collect up those x squareds together, and that will give us 17x squareds is equal to 64. So now I need to divide 64 by 17 to get myself x squared. That's going to be 3.76. And then if I square root that, I'm going to have x. So square rooting that will be 1.94. Okay, we've managed to solve that equation as well using some of our rules and understanding of algebra. Let's try a worded question to finish off. So a thin steel tower is supported on one side by 2 cables. Find the height of the tower and the length of the longer cable. Okay, so let's say that the height of the tower is x. The length of the longer cable is y. We've got to find out those two things. So step 1, start labeling up those sides. Okay, now we are given, first of all, the length 40, which is the shorter of the 2 cables. I've just labeled it in green there. That's supposed to be a straight line. Okay, so if that's 40, well, I can use Pythagoras to work out what I'm now labeling in red, okay, that length there. So that red side is going to be, and let's call that anything you like really, let's call it z. We haven't used a z yet. Okay, so we can say, let's put it in there, look. Okay, that 40 squared, the hypotenuse, is equal to 25 squared plus z squared. So rearranging this to find z, if I do 40 squared, take away 25 squared, square rooted, that is going to give me z. Okay, so jumping onto the calculator, 40 squared, well, that is going to be 1,600. 25 squared, well, that is going to be 625. So if I take the 625 away, I'm going to be left with the square root of 975 equal to z. So now if I take my 975 and I square root that, I'm going to get that z is 31.22. And let's write out, we can round this up later on, okay? Let's put it something like that, okay. Now, so from there, we can certainly work out the height of the whole tower, which I originally called x, because it's going to be z, which we've just worked out, plus 10. So let's write that down. X is equal to, well, it's just going to be 41.22499. Well, let's just say 41.2 for our final answer, and we're in meters. Okay, so now we've got that, we can find y, because y is part of the larger right angle triangle. So let's just draw it out in blue, look. Okay, we have a big, large blue triangle, and we've got the length of 2 of those sides. So we could say that y is going to be 41.2 squared plus 25 squared square rooted. That's the sum of the other 2 sides, both squared, and then we square root our answer. So let's just work that out. So if I do my 41.2249 squared, I am going to get 1,699.5 plus 25 squared. That, of course, is 625. And I square root that. Well, let's just add these 2 values together, 1699.5. So we're going to have the square root of 2324.5. So square rooting that is 48.2. So my value for y, the length of the longer cable, is 48.2 meters. Okay, I hope these examples have helped you to see how you can apply Pythagoras to lots of different situations. Good luck with the questions.